Hello students, week 13 physics for grade 11, chapter 34, lesson 6, Ohm's law and electric shock, part 1, textbook page 686. At the end of the lesson, you will be able to explain the causes of electric shock. You learned Ohm's law in the previous lesson. Ohm's law is the relationship between current, voltage and resistance. You learned already voltage supplies the push, resistance opposes the push, and the result is the current. It means when there is high voltage, current will be high. When there is high resistance, current will be low. What is our body resistance or body's resistance? Your body's resistance ranges from about 100 ohms if soaked with salt water and to about 500,000 ohms if your skin is very dry. Touch the electrodes of a battery with dry fingers and your resistance to the flow of charge would be about 100,000 ohms. So you would not feel 12 volts and 24 volts would just barely tingle. Means there will be no electric shock when you touch 12 volt or you can say 24 volts with a very dry hand. With moist skin, however, 24 volts could be uncomfortable. So the important point here is, if your body is soaked with water and especially salt water, resistance decreases to 100 ohms, but otherwise it can be 100,000 ohms as a range if our body is dry, and if the body is very dry, it can be 500,000 ohms. You can see here this table, difference in the current causes different effect in our body. Regarding electric shock, if the current is 0.001 ampere, we can feel the electric shock. If the current flows 0.005 ampere, if it flows through our body, it will be painful. If 0.010 ampere current flows through our body, it can cause involuntary muscle contractions. And if the current is 0.015 ampere, there will be loss of muscle control. And if the amount of current is 0.070 ampere, and if it is flowing through the heart, serious disruption, probably fatal if current lasts for more than 1 second. So death can also occur. So remember, 0.070 current ampere current is enough to kill a person. So we should be very careful regarding handling electrical appliances, and also we should really be careful in our body's resistance not to be lowered. Many people are killed each year by current from common 120 volt electric circuits. Touch a faulty 120 volt light fixture while standing on the ground and there is a 120 volt pressure between you and the ground. The soles of your shoes normally provide a very large resistance, so the current would probably not be enough to do serious harm. So in handling electrical appliances, it's always better to wear shoes or any footwear. If you are standing barefoot in a wet bathtub, the resistance between you and the ground is very small. Your overall resistance is so low that the 120 volt potential difference may produce a harmful current through your body. Drops of water that collect around the on-off switches of devices such as a hair dryer can conduct current to the user. See, in the previous lesson you learned Ohm's law and you know how to find the current using voltage and resistance. If you check the voltage of the power outlet that you have at home, and if you think your body resistance is let's say 100,000 ohms, so using these two you can know what current could flow through your body if you touch any faulty part of that device. Although distilled water is a good insulator, the ions in ordinary water greatly reduce the electric resistance. You know that distilled water is a good insulator, but the water we actually have at home, we use at home, has ions. So they are not pure water, they are not distilled water, so definitely there will be current flow. So there is also usually a layer of salt on your skin, which when wet lowers your skin resistance to a few hundred ohms or less. Handling electric devices while taking a bath is extremely dangerous. Definitely we should not do this because wetness will decrease our resistance and will increase the flow of charges. Handling a wet hair dryer can be like sticking your fingers into a live socket. So we have to be careful in handling electrical appliances. If you have any question, we can discuss this in the next part. Thank you. See you next time.